Hello, hello, hello everyone, and welcome back. We're still looking at the 2011 Fermat paper, and we are on to question number 24. Four numbers, w, x, y, and z, satisfy that w is less than x is less than y is less than z. Okay, so they've got a clear order. Each of these six possible pairs of distinct numbers has a different sum. The four smallest numbers are 1, 2, 3, and 4. We don't know what the other two sums will be. What is the sum of all possible values of z? Okay, so what are the six sums that they are talking about? Well, there's, so we've got w less than x, less than y, less than z. So you can have w plus x, that's a pair of numbers being added up, w plus y, w plus z, x plus y, x plus z, and y plus z. So these are the sums, and they're telling us that four of them are known, and their values are 1, 2, 3, and 4, and these are the smallest ones. Now, thanks to this information over here, we can tell some of the order. For example, y plus z, this is the sum of the two biggest ones. Y plus z is the largest of the sums. Similarly, w plus x is the smallest of the sums. Okay, can we learn anything else? So, for example, w plus x has to be 1. It's the smallest of the sums. Now, how do I know it's the smallest? Well, think about anything else. Think about, say, w plus y. W plus y, well, y is bigger than x, and they've got w in common, so this should be greater. So what we're going to do is we're going to place that above it. Okay. What about, say, x plus w? Well, x is greater than w, so you can definitely say that x plus y is greater than w plus y. And similarly, say w plus z has to be greater than w plus x, so you can work a lot of this out. And you can go backwards from the top. You can say x plus z has to be less than y plus z. Okay. But there's one other one that we're missing, w plus z. It's hard to tell the difference between wz and y plus z, because we don't know how far away w and z are and x and y are. Okay, but you can definitely say that y plus z is greater than x plus z. You can definitely say that x plus z is greater than x plus y, because z is greater than y. You can also say x plus z is greater than w plus z, because x is greater than w. You can say w plus z is greater than w plus y, and you can say x plus y is greater than w plus y. And you can see that w plus y is greater than w plus x, all based on this sort of order relationship that we're given. So we know the smallest ones are 1 and 2, and then the next two smallest, I can't tell the difference. I can't tell which is smaller between these two. But I know they're definitely smaller than these two, y plus z and x plus z. So one of these is 3, and the other is 4. And that's where we get some variation. There's some possibility as to what z can be based on our choices. So w plus x is 1, w plus y is 2, and x plus y. I want to focus on x plus y. I know we're here to find out about z, but if I just look at x plus y, w plus y, and w plus x, these are the three possible sums of the the three numbers, or of pairs of numbers from the three numbers w, x, and y. Okay, so we could say something like, if w plus z is 3, then x plus y has to be 4. It's one way or the other. But if x plus y is 4, we know w plus x is 1. We know w plus y is 2. And if I add all these up, I get 2w, there's 2 x's, 2 y's, and I get, in total, 7. So w plus x plus y is 7 halves, or 3.5, whatever you want to say. And now if I, say, take this first expression, x plus y equal to 4, and I subtract it away, I see that w is going to be, well, 7 halves minus 8 halves is negative 1 half. the x's over here cancel and the y's cancel. The only thing that's left is w. Okay, well, I know that w is negative a half, and I know that w plus z is equal to 3. So we can rearrange and see that z is 3 plus a half, or 6 halves plus a half. So in this case, z is 7 halves. But that's not the only possibility. W plus z could be 4. If that's the case, we do the same sort of stuff, but now x plus y is 3. Now we get a sum of 6 over here, still 2w, 2x, and 2y. And now w plus x plus y is equal to 6 over 2, which is 3. And we can still subtract off x plus y, which is 3. And we're left with w on this side is equal to 0. And so this equation becomes 0 plus z is equal to 4. So z is equal to 4. And those are the only two possibilities, because this is the only place that there's variation as to what the numbers can be. All the other sums are sort of put in a particular order. So either z is equal to 3 halves or 7 halves, or 3 and a half, sorry, 3 and a half or 7 halves, or it's equal to 4. So what's the sum of the possible values of z? 7 halves plus, I'll turn 4 into 8 halves, and we'll say 15 halves. So those are that's the sum of all possible values of z. We could work out all the possible values of x and y. We've already worked all the possible values of w out in the process of answering this. But we'd rather just bubble in our answer of D and move right along to our next question. So we'll get a fresh sheet of paper as we, we're at the last question, right? We'll finish off the 2011 paper with question number 25 next time.